So we'll take a look at the drag chute example one more time from class. So we have a drag chute that's released at time t equals 0. The velocity of the airplane is defined by a function of t. So I'm going to rewrite that expression a little bit differently just to make sure that we've set ourselves up pretty well for the derivative that we're about to take. So I know the acceleration is the time derivative of velocity. So we'll end up using the product rule and the chain rule to get this done. And so we end up with 80 times -1, the quantity 1 plus 0.32 t, now to the -2, and we'd have a trailing 0.32 after that, and we just kind of clean that up a little bit. We end up with the acceleration as a function of time of minus 25.6, and there's our 1 plus 0.32 t to the -2. So then all we're going to do is just to answer that first question about the acceleration at time t equals 3, we're just going to go ahead and plug in time t equals 3 right there. Now, how far does the plane move? Right, we want to know its position at S10. We'll say that it starts at 0. Right? We know the time starts at 0. And I know the final time is going to be 10 seconds. So we're going to use the kinematic relationship between velocity and position. We're going to separate and we're going to integrate. And I'm going to integrate from the initial time to a general time. I'm going to put that function v of t that we were given and on the right hand side I'm going to integrate from the initial to the general s. I know that the initial position was 0. I know that the initial time was equal to 0. And so what we got to make sure is that we can execute this natural log. You can think of it as using u substitution, giving us du of 0.32 dt. And so when we do that, we end up with the natural log of u, and then we've got our 1 over 0.32 that's going to be out in front. And so if we substitute in our values, right, evaluate, we end up with a very nice expression for s of t, right? This is going to be for any time. This would be the position. There's a natural log of 1 plus 0.32 t. And so to find the position at 10, we're just going to plug in 10, calculate it, and it comes out to 358.